Happy Friday, everybody. Today you're going to do a couple of things for me. So you're going to learn about ions today, and we're going to retouch on the Lewis dot structure. Lewis dot structure is talking about the valence electrons, the outside. You guys already know that when you're looking on the group number is going to tell you the amount of outermost electrons. So group 1, like hydrogen, all the way down to francium, they're going to have one outer electron. So you're going to start off the period by filling out this organizer. So this is the dot notation and ion formation organizer. You're going to start by filling that out at the start of the period. After that, you guys are going to fill out a pogiel. This one is the ions pogiel, and the question you're going to be looking at are, how are ions made from neutral atoms? So how do you go from being a neutral atom with a charge of 0, same number of protons, same number of electrons, to an ion with different numbers of electrons than protons? So you're going to be doing this packet. You're going to work with the partner next to you. If you guys need to, you can also turn around and work with people behind you. You each have one of these packets to complete. It shouldn't take you very long. I did it yesterday in like 10, 15 minutes. There are answers. So the sub has the answers for you guys today. So if you're like stuck, like really stuck, you can ask him and he will have the answers to like kind of guide you. Don't just copy it word for word. Look at the explanation on there. I did write some explanations as the farther you go in the pogiel, where it asks you just more questions at the end, the essential questions. So you guys have this packet to complete after you do the organizer. And then in a group of 2 to 4, you'll be making a video either on Flipgrid, or you can make one like I am right now using the Chromebook. And you can post that one to Google Classroom if you use the Chromebook. Flipgrid, though, there is the code, and that code is on Google Classroom under the assignments. It's ions and Lewis dot structure, Flipgrid, or like mini video is what it'll be listed as. And that's at the very top under Unit 2. It'll be like the first thing on the screen, aside from this one. So when you're filling out the dot organizer, you guys are each going to get one of these. And we're going to look at what valence electrons are and the Lewis dot structures. So a valence electron is an electron in the what? What energy level? It's going to be the outermost energy level. Outer, O-U-T-E-R, M-O-S-T, outermost energy level. And this is an electron available for bonding. This is talking about how we can put them together. How does this singular atom become more than one stuck together? That's bonding. Octet is a group of 8 valence electrons. That's the octet rule. It wants 8 to be happy. Noble gas configuration, valence electrons equal to that of a, so it's equal to that of a noble gas. That's when we tried that one for fun in class, that noble gas notation where you had the brackets and you would have the 1s2, 2s2 following the brackets. So noble gas configuration is valence electrons equal to that of a noble gas. For most elements, a noble gas configuration is an octet. For a few of those that are smaller, like hydrogen and lithium and helium, those ones have a configuration of 2. So a cation is something that is positively charged. It's when a metal loses an electron. It loses an electron. And an anion is a negatively charged ion formed when a non-metal is going to gain. So cation, that's going to be the left side of the table, is going to lose it and become positive because it's going to have less electrons and more protons. And an anion, those are like the noble gases, halogens, all of the nonmetals. they're going to become negative when they gain those electrons. So metals lose electrons, forming cations, and nonmetals gain electrons, forming anions. That's just a little vocab for us to look at. The next thing, so we're going to look at valence electrons. So we're in group 1. Remember, the group number is going to help us know the valence electrons. So for valence for group 1 sodium is going to have 1 valence electron. Group 2 for magnesium is going to have 2. Aluminum, group 13, 3. And you continue the pattern as you go down the periodic table. Next is the electron dot notation. So you know how many electrons it has based on the valence. That electron dot notation is also known as Lewis dot structures, Lewis, Lewis dot structures. So this is where you put the element name. So you're going to have Na for sodium. Sodium has 1 valence electron. So you're going to put 1 dot next to it. Magnesium, that's Mg, is going to have 2. And you're going to notice I'm putting them as far apart as I can. So sodium's is right here. Magnesium, they're on the opposite sides. Aluminum is going to have 3 at different sides. Silicone is going to have 4. Same as carbon. They're all going to look the same. Phosphorus is going to have 5. So we're going to go 1, 2, 3, 4. And then we're at the top one, we're just going to add another dot. And we're going to have 5 dots for phosphorus. Then you're going to go to sulfur is our 6th one. And have 1, 2, 3, 4, 5, and 6. And our last one is chlorine. 1, 2, 3, 4, 5, 6, 7. Argon is our noble gas that we get to. Ar, and it's going to have all 8. There will never be more than 8 valence electrons for the Lewis dot structure. Or when talking about valence electrons, there will never be more than 8. On your homework, we talked about things being lost and gained. So electrons lost or gained. Your sodium is going to lose, it's in group 1. It's easier to lose an electron than it is to gain one. So you're going to lose 1 electron. Magnesium, same thing. It's less than 3, so it's easy to lose. So magnesium is going to lose 2. These valence electrons for aluminum, 3. It's going to lose those 3 to get that octet lower. For silicone, silicone's that weird. It's going to either, this is going to be to share, to form covalent bonds. That's COVALENT. So they're holding hands. They're sharing electrons. If you have 2 carbons together, they both have 4. They share those 4. Now they have 8. So these are going to want to share to get that 8. Then you go past. You go to your 5. Your 5 is going to want to gain 3 electrons. It's easier to gain 3 than it is to lose 5. Your sulfur is going to gain 2. Chlorine is going to gain 1. And octet, they're so happy in that noble gas area, they're not going to gain anything. They're not going to lose anything. When it's asking you what ion is formed, for this one here, which ion is formed? So you're going to use the same element name, sodium. Sodium is going to lose 1. So you're going to have a +1 charge because there's 1 more proton than electrons now. For magnesium, that's going to be Mg +2. Aluminum, Al +3. For silicone, it's going to be Si for silicone. So you're starting with silicone. Think about it for a second. So for silicon, you're just not going to write anything. You can put like none, or you can put a little X in the box. We're not going to fill that one out. For phosphorus, anything in that group 15, so P -3, that -3. It's going to gain 2. Now it has more electrons. So you're going to have sulfur, S -2. Chlorine is going to gain 1, Cl -1. And then for the noble gas, there's nothing. So that one's none also. So it's not going to have an ion. And this is how you guys would fill out the chart. There will be one of these available also, like an answer key. But this is just to explain. So valence electrons are the outermost electrons.